Okay, hello everyone. Welcome to a live stream that is studying the basic computational something of multicomputation. Sort of a mixture of science and technology here. All right, we got a number of things we're going to talk about. We actually had backed into talking about some of this yesterday in talking about how to scan a graph, but I think we're going to be covering mostly different things today. So let's get into it. All right, trace graph and trace tree from Ian. Let's see, do you want to, so these are now things in the function repository, is that correct?
Yes.
And
trace tree is something that we haven't properly reviewed, aside from bringing it up in the trees design review that we needed to look at it again.
could somebody just give me the nestedly recursive function that I seem to test this on every time? Do we have that?
What?
Do we have that? Anybody know what I'm talking about?
Ian, do you know?
I remember. I'll have to look for it.
Okay. All right. I want to make this. So why is this trace graph? Okay, so let's make sure we understand what's happening in this trace graph. So we've got an expression. The dot, dot, dot means an evaluation. The red dots mean an evaluation. Is that correct?
Yeah.
Okay. This thing means what? It means a sub expression. Is that correct?
Yeah, that's a subsidiary evaluation.
So in a sense, this is kind of drill down into the expression. This is kind of an event. So Nick and others, I kind of want an analysis of what's going on here. So I mean, we've got, let's see. I mean, normally, okay, in a full multi-computational picture, every event is for itself, so to speak. And if we have like a list of, we have a whole hypergraph full of nodes, every node and every sort of cluster of nodes gets updated independently. That's kind of the multi-computational way. What we're doing here is we're saying there is a specific ordering. I mean, this is related to our graph traversal stuff. There's a specific ordering in which we're going to visit these things. But here, you're showing those two different orders as kind of space-like separated things, sort of independently coming out of this expression. That making sense?
Yes.
Now, the multi-computational version of this, let's just make a bigger one here. Okay. And I assume, by the way, that, I mean, this is nice, by the way, yeah, just to say. And I mean, I assume that I can give options here, like aspect ratio arrow 2 or something.
No.
You should make that work. Any reason to not have that work?
It's just an additional layer of polish to add.
Yeah, okay, fine. Because I think this is heading for a system function, but it isn't quite there yet. Okay. So let me just understand this. Okay, another question for people. Do people think this is useful for debugging? Or is this still, and what would make it useful for debugging?
Not sure. Just it needs to develop some feeling around it. How to use it with some filtering, because usually it's going to be big.
Yeah. Well, I mean, trace itself has certain filtering characteristics, but I mean, let's just understand this. What is the multi-computational version of this? Because this is two space-like separated pieces, or maybe we call them tree-like separated, I don't know, but there are two pieces here. I mean, they're really tree-like separated pieces, and I don't quite understand. I don't understand how they're snarfed back up into a tree. So there's 5 minus 1, but how does it know that it gets rewrapped with a fib there? Do you see what I'm saying?
Yeah. Yeah, I have that question too.
This is a drill down, right? We had this in the Combinator post. Ian, do you want to comment on this? Ian, do you
Yes,
understand?
I just put that function that you were using in chat.
Okay, great.
How does it remember the fib?
Yeah, how does it remember that it has to rewrap this with a fib? See the question? Yeah.
Are you asking for the implementation or
No,
how you can tell
we're
from the
asking
picture?
how we can tell from the picture. What is it? You know what I'm saying? See here,
Mm-hmm.
Like
this,
we lose the fib, right? Just to 5 minus 1 goes to 4, and then we get the fib back again. How is that information being kind of passed along?
It's because the default value of trace original is false. If you do trace original goes to true, then it includes the expressions both before and after evaluation.
okay, so if I did the same thing and I did trace original arrow true, oops, in there, right? Is that correct?
Mm-hmm.
Maybe I should do a smaller one here.
Right. So the node that was previously unlabeled, because it was just a placeholder node, now has the original fib of 4 minus 1, which is the expression before evaluation.
Okay, so there's a deconstruction process here. Everything that's coming out is being drilled down into, except for these ones, right?
Right. The round nodes are things that have subsidiary evaluations, and the square ones are ones that don't.
I see. How the hell do we know that 4 minus 1? I mean, it just so happens that 4 minus 1. Oh, I see. That's an assembled thing because it's
Yeah, you can tell those are reconstruction edges because they're going from a square to another square.
Okay.
If it was round and had an edge, then you would know that's an edge for a deconstruction. But since it's square and has an outgoing edge, it's a reconstruction.
Okay.
Okay, and I see that the fibs are literally being passed now. Okay, yeah, I see that.
So let's look at this one here. Three minus 1. Okay, check its sub-elements. Okay, it's just 3 minus 1. There's nothing to no sub-element. By the way, I think that it might be worthwhile to have an option here to suppress things like this. You know what I'm saying? Where things that evaluate themselves.
Yeah. What do you think of the name trace trivial for that? Like trace trivial goes to true or false.
Wasn't it called show original? So maybe it should be show trivial, although that's a little bit weird.
Where's show
Well,
original?
Trace original is the name of the option.
Oh, never mind then.
And there's basically, right. So trace original does two things. It compares expressions before and after evaluation, but it also includes things that trivially evaluate to themselves. So there's effectively an option trace trivial that has the same value as trace original.
I don't really like trivial. I think there's nothing trivial about this picture. I think something like
but if you could set that to false and have trace original goes to true, I think that would be more like what
is the name trace original actually sensible?
Yeah.
Explain it.
So there's a second argument of trace that is a pattern that you compare to the expressions. And by default, it's only comparing that pattern to expressions after evaluation. So trace original also pattern matches against the original expression before evaluation.
Okay. Well, I mean, look, for the WFR function, trace trivial is, I don't know.
But an additional behavior is that it does this thing where it includes things that evaluate to themselves, which you may want one but not the other. Like they should be independent.
Look, trace self-evaluation. Arrow true or false, maybe.
Mm-hmm.
It's kind of like self loops, you know? I don't know. I prefer trace self-evaluation. Any comments on that? Suggestions for that?
Is
Anybody?
self-evaluation already taken for something?
I don't think we want to use it for this. This is I think that could mean, no, it isn't, but it could mean many things.
Yeah, okay.
Okay, but so fine. So then that will remove some of the pieces here.
Mhm.
But otherwise,
And by the way, that same option could be supported by trace.
absolutely. I mean, trace, look, the understanding of what the heck trace actually does is, you know, is so obscure at this point. I mean, this is kind of an interesting way of showing how the evaluator works. What's a good example that shows sort of the evaluator? I mean, if we say f of 2 plus 1 plus g of 4 plus 6, my God. Okay, it's kind of showing how the evaluator works. Possibly even mildly useful. Again, I don't like, it would be nice if we could annotate a deconstruction and a reconstruction edge separately. Do you see what I'm saying? There are two kinds of edges here.
We just need an idea for what to use. Right now, you can tell from the shape of the parent node, but that's subtle.
That's very subtle.
Are there tags on these edges? Like what position was this sub-expression?
That would be useful.
There's not currently, but I think, yeah, the right thing to do would be for these to be tagged with the position. And also
Right,
things like the label is a formatting thing. It's not really accessible as an annotation, and it probably should be.
Fine. So, okay, so look, what we need here is, okay, what is our, okay, first question for Nick. Is there a sort of a token event interpretation? What is this graph in our lexicon of types of graph? I mean, this is the non-multi-way, this is a single way evaluation graph, basically, of which there will be a multi-way version, correct?
It can be. This is basically a subgraph of a multi-way that only deals with spatially separated evaluation. There is no overlapping sub-expression being evaluated, right? So all of them are spatially separated. So it's just a subgraph.
Right. But okay, but look, we got to label two kinds of edges. I mean, so this edge here, this is where we need design. I don't know, maybe somebody could see if we can get Jeremy or somebody to join us for a moment. We need to do our colors again. I mean, just so people know, like in the physics project, the fact that we chose canonical colors is just super useful. Go ahead, somebody was going to say something.
Well, I was just going to say, I mean, look, I think there are two slightly confused purposes of this function. One of them is debugging, and the other one is sort of, it's a picture that lets you understand how things are evaluated for sort of educational value. I mean, I think, for example, for debugging, I think that having every single property of the evaluator be represented, I think is probably not useful. I think,
yes, I
think
agree.
it's probably just going to be confusing. So I mean, I think there's a trade-off between comprehensibility and how many colors and things we use. And I'll note that at the beginning of every one of these meetings, we spend about 20 minutes where you say, okay, let's understand what this function is actually doing, and then you put your, the same example and so on. So
yes,
I'm not sure it's a good idea to go further in the pedantic but incomprehensible direction.
well, it might be helped by having, look, these edges if this had an indication that it was a drill down edge, and it isn't even, one thing that doesn't help is that we don't have ports in graphs, right? So this plus is actually earlier than this. See what I'm saying?
Right.
And, really what we want to indicate on this edge is that it is a drill down edge. I mean, if it wasn't for the fact that arrows mean something different on graphs, I would think that the drill down edge, and how can we represent? This is something being deconstructed. This is something being reconstructed. Okay, let's see if Jeremy has an idea. Okay, let's look at trace tree for a minute here.
One comment about debugging. So I do use trace for debugging quite frequently, and there are typically two phases to the problem. One is finding the area of the trace that you are interested in, and then the second phase is looking at that area. So what I'm wondering is how can this be changed to help in the first part? So I think this would have to involve some sort of openers.
I agree.
You click on the area that you know, or perhaps a position finding. When there is a message, it's typically quite fast to find where that message was emitted in the trace.
Yes. Well, it should be very fast. If there isn't a good way to do that right now, we should make one. Some kind of trace message type thing, which just gives you the window around that, around where the message was generated. Look, trace is a super old function. It came from 1990. It was an attempt to understand, it was an attempt to do this, basically. Okay, I agree that the openers thing is important. I believe that openers are coming to graphs. And if that's not part of the global project list, it should be. Openers and graphs. Could somebody make sure that gets added?
Yes, I will.
Okay. So, where was I here? I mean, so look, openers and graphs are not going to come specifically from this project. This is a good application for openers and graphs. We know we need those for many purposes. So you were making a different comment, I think, about, the question is this useful for seeing sort of the overall flow of a program? I don't think we've tried it for that yet. It's certainly not going to be useful at the level where it's showing you all the microscopic pieces.
Right. So the output of trace is typically very large. So we need to be able first to go to the area you are interested in.
Right. Here, how do I get it to do this without showing labels? So if I say f of 4, for example, boy, how do I get this without all its labels? How do I get just the graph?
There's not an easy way right now.
Okay, there needs to be.
Doesn't play well with options.
There needs to be. Can I just say graph of this and, graph, what do I say?
Because I'm reusing the tree shape function, which is kind of special because it wraps around the label.
What does this do? Why didn't this work? It's giving an aspect ratio here. Why didn't that work? What's going on here? Okay, I don't understand what this is doing. Do you understand? So this needs to be fixed, basically. Right?
Yeah, options.
Well, it's just not working, right? So okay, well, anyway. Okay, so how do we get rid of the labels here? Is there any way to do it? Because we're going to need that.
You can do vertex shape function goes to none.
In what? In the
reoptioning graph.
Didn't work.
Try all arrow now.
Oh,
it's an underscore. It's a button, right?
Really? Is this right for this thing? F of 4 just does a straight line evaluation? I just don't believe it.
If you do trace original goes to true.
Okay, that's what we've seen before. So, I mean, okay, and then what we got to think about is the multi-way version of this. What does that look like? Because that was our original objective here, is to make a multi-way trace, which I suppose is basically a version of the evaluator that has been made multi-way. Am I correct?
Yep.
And I think that's what we want. Go ahead.
Well, I had some version of it, right? Just by doing rewriting rules, replacements.
Yes, where that's the only operation.
Yeah.
Where we don't have, but I think we also want these actual, down code evaluation type things as well.
No, we can just take this trace graph and I don't know, splice it into a multi-way graph where the actual evaluation happened.
Okay.
So all the replacements are multi-way, but when we actually go into evaluator, we just make a trace graph and splice it back. You can do something like that.
I see what you're saying. Well, the replacements and perhaps, right, but okay, in a list, for example, the things are space-like separated. Okay, here I think we have Jeremy here. Let's do a quick session on doing colors. Okay. Jeremy, are you with us?
Yeah, I am. Yep.
Okay, this is an evaluation, a trace graph. This shows the evaluation process. Okay. There are two kinds of edges. One where you are drilling down into this expression and evaluating its subpieces, and the other way you're assembling up to take those subpieces and put them together into the final result. Does that make sense to you?
Not really.
Okay.
So I get the first one. So what do you mean evaluate up?
What I mean is, you've got G of 4 plus 6, grind, it turns into G of 10. Now you've got to reassemble that expression to be 2 plus 1 plus G of 10. You see?
Okay.
Those are the pieces that reassemble to that expression. And then that expression gets evaluated by the internal evaluator to give 3 there. Okay, so our question is, we've got 3 kinds of edges. We've got the deconstruction edges, the reconstruction edges, and the evaluation transformation edges. So my question is to think of a clever way to color those edges or to otherwise indicate what kind of an edge they are.
Okay. And how does that relate to the shape, the box shape?
Well, right now, the box shape and color, I mean, this is a end of the line object that does not evaluate further.
Okay. Yeah. All right.
Or does not, no, I'm sorry, that doesn't deconstruct further. Like this one has been deconstructed, but it still can evaluate to something. Right, this is post-deconstruction, this is pre-deconstruction.
Okay.
So, I mean, maybe we want those to have different colors. Maybe we want some way of indicating pre versus post. How would we indicate that? Pre versus post, like green versus red or something. I don't know. You know what I'm saying? And it's like, how do you indicate this thing here is an input, this thing here is an output in some sense? Or at least this thing has been processed, unprocessed to processed. I mean, I would say maybe unprocessed has some kind of grayish background to indicate that it's still, shimmering, whereas this is more locked in, if you get what I'm saying. Comments from people about that. I think that's actually a decent idea. This one is kind of uncertain and in the fog, and this one is more certain.
Yeah, that's how we did mathematics and rewriting expressions. but we usually didn't reconstruct it, reconstructed back. We just replaced everything in place. Right, so it's like if that an original expression was just changing inside of it instead of just deconstructing it back. It would
Wait a
be
minute, what do you suggest?
a
What do
much
you-
shorter graph.
Give me a section. Which section here?
I think it's just the first one, almost.
Here.
When we just have this column of changing expression.
These ones here.
Yeah. It's like
Okay, so that's showing which piece was active to do the rewrite.
right. And you don't need any deconstruction, reconstruction. Just highlight what changes, and you can collapse everything in between without. You don't need to show it in the graph, I think.
So you're suggesting we can simplify this graph.
Yeah, that would be a nice option. Just collapse every deconstruction, construction piece and just put the vertex that shows the change in place.
So what would that look like here? That would look like, in this case, well, there wouldn't be anything there, but I mean, if I were to do just, well, let's do this. List 1 + 1, 2, 3.
You basically only concerned with that dashed red edge, evaluation edge. So you don't care about any deconstruction. You just care about evaluation events. So you highlight whatever piece was evaluated and the position, right? And what position a piece
Yeah,
was
but look, but I don't understand that. Look, if we have this, we've got two different pieces that get evaluated. So how do we indicate this?
Well,
We've
just
got
show
two
the whole expression. You just show the whole expression with one piece changed inside of it.
But then you're showing it twice. I don't understand how we do that in this case. We've got one place where this goes to 2 and that goes to, and another where that goes to 4. Is that correct?
But it's going to be maybe not in parallel, but sequential in this case. It's going like
I'm
event.
confused by how we would indicate this. Do you see what I'm saying? I mean, I don't understand how we indicate this. This thing is lit up here. This thing is lit up here. How do we know which of those leads to which thing here?
Couldn't
It'd
you
be a
just give them
different thing
different highlighting colors or something?
No, we're not. That's never going to work. I mean, look, the perfect way to do it would be this has an ordering. Okay, if we had ports, we could just have the output be based on those ports. Otherwise, yeah, but look, I don't understand, Nick. I don't understand this because each piece here,
Yeah.
in this case, we're doing one element at a time. And I agree with you that this type of indication of what's going on here is fine, but then it'll look just like this. It'll just show this is what happened at each step. And much of what's there, once you drill down, like this step here, 1 + 1 goes to 2, it's never going to show that subpiece on its own. It's just going to show 1 + 1, that's red. Then the next step, it's 2, comma 2 + 2, 3, and so on. It's going to be a series of, it's going to be a sequential. I mean, it's a worthwhile thing for us to have. Maybe you could build that, Nick. Something where you're seeing the evaluation process just one step at a time, where what's happening is each evaluation is just being lit up. Does that make sense?
Yep.
Stephen, can you do trace graph of like fold of f comma x comma range of 5?
Ah.
So this is an example where you have subsidiary evaluations that are not just sub-expressions of the expression. right? The fold of f comma x comma list 1, 2, 3. It has 3 subsidiary evaluations, but none of them are sub-expressions that can be highlighted.
I see, because it generated code on the fly.
Right.
Right. Okay, let's just tackle the thing with Jeremy. Okay, so in each case, we've got a before and after, right? We need a before color, we need an after color. We also have this edge here that is a drill down edge, and we have a reconstruct up edge. Who has an idea for visually how to indicate that?
Would before and after take care of that? Do you need edges on top of coloration for before and after? I feel like you're gonna get what you need with just the nodes.
Possibly. It's just not dramatic enough with what Ian has done with rounding and square. Maybe that's what we need.
And is the third color this transitional, like the between what you
Yeah.
had shown, these pieces, that's some third transitional color?
That's a color where it's actually doing something, right? That's more like an event. You know, that seems to me like it should be sort of an orange event edge of some kind. What do other people think about that?
Yeah, that's an event. Yeah, it's an
But-
orange color traditionally.
But for nodes, is that a before for range 3 going to an after with 1, 2, 3, because it's heading to this next node?
It's an after going to another after.
Okay.
That's not necessarily an after, because there could be further evaluation there, as there is in the case of fold.
Yeah,
In other
and
words,
there
that
ha-
thing
that-
could construct something.
it's a coincidence, you know, that could have gone to something that was round and did need further, but list 1, 2,
Okay,
3
let's
doesn't.
take a look at what that does in a particular case. So let's say we say here, you know, nest list hash plus 1 ampersand 0, 2. Okay, I claim that is going to give, boy, evaluation is a complicated business. Okay, so does that have a subsidiary? Yeah, that goes to 0 plus 1.
Exactly.
So this orange edge goes to an unfinished thing. Okay, and we're going to have this mechanism where we say trace self-evaluation goes to false. If trace self-evaluation is false, this thing ends there. So then it would go to an output, you know, a drilling is finished type expression, right?
Yep. Like you have the 0 plus 1 that's round and the 0 plus 1 that's square, and you would collapse them into just one node that's square.
Yeah, exactly. Right, but that would be something where, I mean, so it just needs its color for the it was finished. You know, I'm not totally sold on the fact that these are just gray edges, but it might be right. Okay, so the it's finished color versus the it's still hot. You see what I'm saying? I mean, maybe that's the way we should think about it. It's still hot versus it's over. Jeremy, what do you think about that? Some kind of pinkish color for this, and then this is a bluish color or something.
That makes sense, but some of these, the before is, you said gray?
No, I'm changing my mind about that.
Okay, all right.
Okay. So then this becomes orange, sort of a bright orange event color. This becomes, you know, it's still pink, it's still embers
Like the orange on the right.
on the right. I don't think it's quite the same orange.
Okay.
It's more an orange that is our token event graph, our yellow color, but we don't want yellow. It's because it's a thin thing. So Jeremy should spec it. Okay, let's continue because we've got. And by the way, it's also got to work when it is small. It's got to work when it goes small like this. But hopefully it will. I mean, where the I mean, I don't know, the vertex shape function. Yeah, I mean, where it just goes down. I don't know what the options are here, and whether you should say trace labeling arrow true or false or something. Making sense? Ian, it's just like your unlabeled tree idea.
I feel like vertex labels, or vertex label goes to none should just work.
That's fine. That's fine. But then that's going to need to be a different color spec for that. What was this again?
It's a placeholder.
What does that mean? What would, for Jeremy's purposes, what color should that be?
The same as the square or the rectangular.
So what does that mean again?
That means that's a form in the subsidiary evaluation that's from a reconstruction, but it doesn't match the pattern that you specified. So there's just a placeholder there.
Okay, it doesn't match this pattern of what we're looking at.
Right.
But it is necessary. It is an expression which will be used again to make this result, which is a 5 or something, whatever it is down here. But we're not showing the 5s because we're only showing the underscore fib expressions that got generated, right?
Yep.
Okay, so I think that's a different color. And I think that color should be some kind of gray color that indicates, because we're never going to have a pre-evaluation version of this, are we?
Yes.
What does the yes mean? Yes, we're not going to have a pre-evaluation version.
There are pre-evaluation versions. They're small circles.
I see. So, okay, so this then has the same colors, the blue and the pink color. All right, okay. Can we move on here? Let's look at trees. I'm not sure if Jeremy's going to be needed for this. What is trace tree?
Could I show you what I've got? Because I'm not fully
Yes.
following all of this.
That you share?
Yeah, I could share for a second. Okay, roughly, kind of the pre to the post to the evaluated, and then I left these as
The wrong
gray,
way
but
around.
wasn't sure.
It's the wrong way around. Okay.
Okay.
So that the pre is still hot.
Okay,
Um,
I'll just do it quickly and choose better colors.
okay. The post there is cold.
Okay,
And that 10, yeah, the 10 is still hot, and maybe that reddish color is actually not a bad color.
and I
Now,
wasn't
I
sure
don't-
what this was, how it related to these two.
Well, anything that's square is cold, right,
Okay.
guys?
That means
Anything
we
that's
should
rounded is still hot.
That would mean that there'd be 2 colors, not 3.
Correct. There are 2 colors, not 3. There's no
So
gray.
The 10 would be blue, and the other red one would be orange.
Those would all be blue.
Yeah, okay.
But I still then think that the reconstruction edges are okay, so that 10, could you just make the other things at the top that same red color?
Sure.
No, not the plus, not the plus, not the plus. Oh, I don't know.
Oh yeah, I was gonna pull it out, yeah.
Okay. I mean, I think these colors are not quite the right colors. But,
No, I just wanted to get the right kind of things labeled properly.
10
right,
should be
so
blue.
the which?
The 10. The red 10 should be blue.
So it's pretty weird that the 4 plus 6 is cold But then, okay, so if you just solidify that line, the evaluation line there, that's currently dotted, I
Mhm.
think that again needs to be a somewhat intense thing there that's somewhat thick. Oh, I mean, if it's too difficult to clarify, don't worry about it.
That's not a big deal.
Okay, bright and thick for that line, I would say.
Okay.
Hey, talking of designs with the wrong set of people here, but did you work on the quantum framework stuff, Jeremy?
Billy did. Yeah, he's got a good start to it. I think he was
Yeah.
working with them
Fine.
to make sure it's the right direction.
Good, fine. All right. What do we think about this coloration? I think we're well, it's better.
If you're
Come on,
distinguishing by color now, are you going to continue to keep the different vertex shapes, or are they going to be the same
I don't know,
shape?
that's a Jeremy question.
Right.
But I'm still not clear that these edges all should be quite exactly the same. What could you indicate? How could you indicate in an edge, drill down versus assemble together? Just in a decoration to the edge.
Maybe you use the same color as the node that it's coming from.
No, that's not right. Because look at it in the 4+6 section, right? There are deconstruction edges and there are reconstruction edges, and they don't have, you
The
can have
deconstruction edges come from a red node and the reconstruction come from blue nodes. So I feel like deconstruction
fair enough.
being red and reconstruction being blue makes sense.
We had also discussed edges that increase or decrease in width, though we couldn't agree in which direction it went. Because to me, this is a zooming effect. So I was expecting the deconstruction is increase size.
Oh, I was thinking the other way. I see.
Exactly.
Zooming in. Okay. Well, Jeremy could try that, but I'm not sure if it will look sensible. I mean, okay, so the suggestions on the table are to put a slight red tinge on the deconstruction edges. I think that might be the simplest thing to try doing. And then really that transformation edge is a much thicker, brighter thing.
Mm-hmm. Dotted could work for these guys. It's this kind of breaking apart, which dotted makes more sense for me on deconstruction.
Try it. We can try it. But I think, possibly, I just think it's going to be dotted all over the place. I mean, we could have dotted and dashed in a very Samuel Morse kind of way. Dotted for deconstruction, dashed for reconstruction. I think it's going to look silly though, to have so much dotting and dashing around the picture.
If
Yeah,
it's
I
a
wouldn't do
large
the
graph, is anyone
dash.
even going to be able to discriminate between the two?
No, we just don't care if it's a large graph.
Why?
Because
If the
you're
edge,
only
look
going
at
to
look at
go-
the edges are colored, you'll still be able to tell that if it's a large graph.
Yes, you might.
Yes, even if the vertices aren't labeled, you should
Yeah.
be able to tell that.
That's true. All right. Well, look, let's try a couple of those things. All right. Let me share again. This is looking.
Sure.
This is getting there. I mean, these are. Okay. Explain trace tree for a second.
So trace graph is showing the relationships between the expressions themselves in an evaluation. Trace tree is showing the hierarchy of the evaluation chains. So one subtree equals one complete evaluation chain.
What? Is this some kind of unrolling of the graph above where things are not shared again, or what?
Right.
So this is essentially a depth first traversal of the graph above. Is that true?
I'm not sure.
I mean, this is showing essentially the recursion tree for
The thing is, it does not
Well-
have reconstruction edges, and the passage of time is indicated by siblings. Like you go from one sibling to the next, and there aren't edges depicting that.
I understand, but then you recurse. What is the recursion here? It is, isn't it? I mean, this is
Like you see,
showing-
there's a 1 + 1, and it goes to 2.
Yeah, I get it. That's so that's the evaluation.
Mm-hmm.
No, that's the evaluation event is right there.
Right.
But this is so what this is showing, I think, is the execution process of the evaluator. Recurse, recall the evaluator. I claim a dot is a recursive call to eval. What do people think about that claim?
So this like round nodes are the beginning of a subsidiary evaluation.
Right, so it's a recursive call to the evaluator.
Yeah. But
And
so
what-
you see there's the fib of 3 - 1 plus fib of 3 - 2.
Yes.
So, yep. That
Yeah.
is deconstructed into those next two children.
I understand. So the flow of
And then
time.
it's reconstructed into the 1 + 1.
Yeah, I understand. This is a stack trace, basically. This is an execution history of the evaluator, I claim, where history is going this way. It goes from this to this to this.
Mm-hmm.
And in fact, it goes, well, I'm a little bit confused by this, but this fib of 3, no, where the heck does fib of 3? That's
Do
fib of
trace
4.
original goes to true. It's the same thing that we saw earlier, where there's a 3 and it mysteriously turns into a fib of 3. Now this is actually showing what happens.
Okay, fib of 3, but it doesn't turn into this. I mean, what I'm understanding is that the horizontal axis here, I'm confused. Anybody not confused here? I'm confused.
Hopefully Ian's not confused.
Yeah, aside from me, or
Okay, Ian, explain.
so fib of 3 is the root, right? That's the original expression. It
Yep.
deconstructs into fib and into 3.
Yep.
So those are those round nodes there. Then those are reconstructed into fib of 3, and that's the leaf fib of 3. And then that transforms into fib of 3 - 1 plus fib of 3 -
Yeah.
2. And then that deconstructs into the plus and the fib of 3 - 1. And the fib
This
of 3
seems
-
like a less useful representation than the one above. Or am I missing something?
The purpose of this was to be able to take the output of trace and do expression tree on it. And this is showing the hierarchy of complete evaluation chains from start to finish. The graph one is showing the relationships between individual expressions.
So if I were to do my friendly version of this, oh my God.
Get rid of the graph.
What do you mean get rid of the graph thing?
You have
The
graph.
wrapping.
Oh, I see. But can I say vertex shape function to none as part
You'll
of
have to put tree around it and use tree options.
what are the tree options here?
Let's see what it does without options first. With just tree element label goes to all goes to none. I guess you could also just apply unlabeled tree to this. then you lose the round and square.
I don't think they're helping me very much.
They mean different things.
No, I understand they mean different things. But so this is now, so if we did this for Fibonacci, what the heck is this tree? Why are these things so absolutely huge? That's just wrong.
I have
Why
the
are
impression that, sorry, I have the impression that this is a more faithful representation of what trace returns.
No doubt.
Structurally.
Okay, but why are these dots so ridiculously huge, Ian? It's wrong, right? Why did that? I don't understand.
They have a fixed size.
They shouldn't, right? This is clearly wrong. I mean, how have we done this for graphs?
No, an unlabeled tree, they do not have a fixed size. I believe that's just the default
Okay, it's wrong.
size from graph.
It's clearly wrong. You do recognize that it's wrong, right? You can see that it's wrong here. Do you agree
Apply
it's
graph.
wrong, or do you not agree it's wrong?
Apply graph to it.
That's super ugly. Why are they so big?
I don't know.
Well, you should find out. I mean, who's project managing here? Who's project
I
managing?
am Kristen.
Okay, so it's for you. Can you take that to Charles, please? Find out
Yes.
what wrong. Sigh. Okay. Okay. While we're at it, let's just take a look at this, like f of 5 here, just to get some sense. I don't know, when in doubt, make it bigger. My God.
That's funky.
I mean, I don't even understand the Fibonacci tree here, let alone, I mean, when in doubt, make it bigger. Let's try fib of 7. Okay, what the heck is going on here? And what would this look like multi-computationally? Go ahead, what were you going to say?
I was saying I would need the labels.
The full labels.
Mm-hmm.
I mean, we can certainly get, well, that didn't even do that.
You also have to get rid of trail element label.
Yeah, I know. We can do it, but it's going to make a big mess, right? We're running out of time here, and I really want to look at a couple other things. But and I would like to, okay, can we have a very, very quick look at some of Nick's work here, please?
Well, briefly, it's just a booklet that I implemented all the pattern objects with the pattern matching with some intermediate thing for replacement. So it's like a detailed replacement where you first do a pattern matching. It's what returned by these pattern substitutions. And then you can extract all the bindings and use it like in all the replacement functions, for example.
So you're saying this is how things were bound, and you could just apply those bindings to the original expression to get the result that you would get. Is that correct?
So not to the original, if you had a rule, you apply it to the right-hand side.
The right-hand side, yes.
Yeah.
That's a nice thing. That's a nice thing. Now, did you have to rewrite, did you have to re-implement the pattern matcher to make this work?
Yeah, it's like I implemented all of it. So it's like a level 2 pattern matcher. I used pattern matching to implement all the pattern matching again.
Huh. Okay. This is a very interesting thing. I mean, this should be a built-in function of some kind, I think. I mean, does Christopher or anybody else have a comment on this? I mean, we should have had this like 30 years ago. This, list the bindings.
This works with arbitrary patterns.
Yeah, almost all of them implemented. Like maybe some bugs still there, but yeah.
Is it just implemented with replace basically?
No, you can implement any function with it. It's like pattern substitution is the big function here.
Right,
If you
right.
like-
I just mean that it's implemented like replaces is how this function is internally implemented, right? I'm guessing.
Yeah, it's like have a handler for all the primitive pattern objects, like all pattern sequences except alternative blanks, so on.
What the heck is this?
Yeah, it's like this one looks very ugly, especially with this big context.
But what is the Wolfram pattern substitution sum? What is that?
Well, if you open the link, is there a link to actual Packlet? There's some documentation that I wrote.
What at the top?
Oh, hold on. Let me just fetch it really quick. This.
Is this relevant to compilation with patterns?
I don't think so. I mean, it's just calling replace. It's basically wrap around replace. Then
Where's the is there
Open
documentation?
the guide.
Boy, this is cool. This is a real Packlet.
So the first is like free heads that I use for the object itself. I don't format it yet, but it can be just like formatted with some nice summary box. But the substitution like can be one of those 4 things. It's like very algebraic.
Can I
And then
see
the-
that if I look at pattern substitutions?
Yeah.
What the heck does all this mean?
There are a lot of information inside of it. You should be able to use this object in order to reconstruct your expression back from your pattern and also extract all the bindings from it.
Okay. By the way, point for Kristen, there's a stupid bug with the formatting here. I don't really understand this yet, but this is you claim this is an algebraic representation of what? I mean, this is some kind of compiled representation of the pattern. Is that right?
It's a compiled representation of a substitution of a pattern matched against an expression. It's like after you apply a pattern matcher to an expression, it extracts the information and it knows what all the bindings were at, which pattern object being matched to something and so on, like so that you can actually reconstruct the expression back, all possible reconstructions. So it's like a replace list. You can implement a replace list with it.
I see. So this is a multi-way object.
Yeah, sum is basically the outer head is alternatives, and the product is like all the substitutions that applied at a single instance.
So if we were doing category theory, this would be some kind of monoidal category thing in the outside.
Well, it's more like a ring, I think, just because you have two types of. It's like an algebra. You have a sum or product. It's a product and a coproduct. And you can even interpret part position as some kind of scalar multiplication, maybe.
It's cool. Are
Because
you
they even
sure
have-
this isn't relevant to the compiler, to compiling sort of the process of pattern matching? Because like,
Well,
yeah,
yeah. I mean, let me think. Maybe it could be in the sense of that you basically use the evaluator to get this sort of this representation of the pattern, and then that's what the compiler actually uses if you want to run, I don't know, match queue or something.
yes.
I mean, basically, the question is if this can get a representation of a pattern that's easier to, compile so you can run match queue on it. the normal representation of patterns, then maybe it could be useful for that. But I'm not sure that's I'm not sure that's entirely the problem with patterns in the compiler. Honestly, I think the main problem with patterns in the compiler is just that the way they were initially implemented was not thought through. And so I think that's right. I think that there haven't really been many attempts since then. So I think there may be possible to do a more sane attempt and it will be fine. But
Yeah, this is this is the attempt also. If you open the tutorial page, I have this little small collection of differences with the current. It is match replacing. Inside with there's some differences with the current pattern matcher.
the difference between this and, so this will give one answer and match Q will do something else.
Yeah, or maybe there's yeah.
Are these differences where you think that your version does the right thing and the pattern matcher does the wrong thing, or are they just differences?
In some of it, but debatable.
Well, what are there? Let me see. Are there any examples?
Match Q of a null list and a list with a blank period.
I don't see why that doesn't return true. That seems like a bug.
Yeah.
Well, maybe we should report that. I mean,
Yeah.
like, if it's an
I already
actual
reported.
bug, I think. Okay, yeah.
Like I also went through some bugs that I reported and also some other bugs that I found related to pattern matching.
Somehow, Nick, I have a feeling that you know it's time to put on that diving gear or something and go look at the actual pattern matcher source code.
Maybe.
Good luck.
I'm afraid, yeah.
Sounds like
Part of the thing is that the pattern matcher, whenever I looked at pattern matcher code, it ends up being super, super complicated, largely because, the base functionality usually is not that complicated, but then their edge cases, and in particular, their edge cases of things like attributes, and that just like kills you because it's just, you now have to handle every combination of attributes.
Right. But when I originally wrote this code, and I think it's survived, one of the main things I did was I looked at all these different cases where I thought there were, optimizations for particular cases, and I literally numbered, cases where the different types of things would happen, where you would, be sort of combinatorially enumerating with respect to one index versus another and so on. So it was broken into just an immense number of different cases, which is, not, I think it's good for efficiency. It's not great for maintainability. Well, this is really interesting, and we should look at this some more. And I know I really need to get going, but I just want to know what a branchial wormhole is, and then I just want to look at this one. Yeah. Right. Well, these are all important things. I think we need to follow up with another meeting in this series, preferably sooner than a week, because this is an active thing. We got lots of stuff. Nick, your moment to explain branchial wormholes.
Really quick, right? Okay. so this is a very close to the event branchial graph for the multi-way system. It's a branchial graph built on top of a causal graph, but it takes into account this nature of events. It's like if you have an actual space-like separated events, you don't care. You don't connect them with the branchial edge. You only connect events that are actually overlapping, so that they don't commute with each other.
I see.
So they start to represent this correlation. And
okay, so this is overlaying a piece of branchial graph on top of, I don't understand why. Isn't it? It's like some of these events, you could indicate that they are branchially separated as opposed to space-like separated. Is that correct?
Yes.
So it's annotating this graph with branchial separation.
Right. Yeah.
And then is this a pruned version of this graph somehow?
Well, one of them only contains events and another one with states too.
I see. So
It's
this is annotating which events are branch-like separated.
Yeah. And
Where's
then
the-
you
yeah.
and
Right.
then all those branch-out edges, they also, because they represent correlation, some non-local correlation between events, they kind of slide through the causal edges, right? Because all the events that causally depend on the events that branchially connected also should be branchially connected. So
Yes.
as soon as you connect them, you slide them through the causal edges into the future, and that's this branchial graph that represents all the local correlations between events. So
So this is the true sort of, this is the quantum this is some version of quantum, this is non-spatial relationship between two events. Yeah, okay.
Yep.
There. Okay, what's this thing? Oh, that's the
This is after you slide it through the causal edges.
So this is essentially annotating the causal graph with which causal edges are on different threads of time, basically. Which events rather are on distinct threads of time. Is that right? So anything that's connected by a branchial edge can't occur on the same thread of time. Is that
Well,
right?
it can, basically. Why not? I think it can. Because when you have a overlapping event, that's when we connect those events with
Yes.
branch.
Right.
And it can happen at one particular moment.
I'm fairly confused. Try again.
Well, usually if there's a branchial edge between, two states, right, they're not time-like separated. That's the whole point.
Yes.
Right.
So that's what you're showing here, is the things which can't be time-like separated. But wait a minute, can they be? Are they also not space-like separated? Is that correct?
Well, they are overlapping, yeah. That's the whole point. But we're starting with the overlapping events, but then we just move forward this correlation forward. You can also think of those branch edges, they kind of constrain your foliation because they connect events that are not commuting. So we can't foliate them. They should be in the one particular foliation slice.
They have to be in the same foliation slice, you're saying?
Yeah, because if you were in different ones, you already assuming a foliation that one follows another one.
Right.
So that's different from saying, I'm confused. If two things are space-like separated, there are multiple foliations that preserve that space-like separation.
Yeah.
But
here
you
can't make one. You basically, when you have two overlapping events, you don't know which foliation is correct one because whatever you pick changes your history, right? Because they're not commuting. So both foliations are correct, and you can't just pick one of them. So it's like two multiverses.
Say that again.
You have two universes, right?
Yes.
As soon as you have an overlapping event, it's branching. And you just represent it with one branchial edge between those.
I see. And that's why you're calling this a branchial wormhole.
Yeah.
It's because it connects two universes, basically. This branchial edge is the connection between two distinct universes with different histories. Is that correct?
Yeah. And if you just look at it like that, it connects events, because you can actually compute the distance in the causal graph, usually, right? By longest path in the causal graph. You can compute time distance and space distance. But if you have this branchial edge, your effective distance is going to be smaller because you have this additional correlation between those.
Yes. Hence, spooky action of distance in quantum mechanics and other such things.
Yep.
So your point is, this is pretty nice. There is a notion of this construction of space-time that has certain distances between events. But what you're doing is you're annotating that by branchial connections between events, which are sort of on different threads of the multiverse, so to speak. And which may be nearby in branchial space, but far away in causal space, so to speak.
In space-time, yeah.
Yes. And so these things, so that's why you're calling them branchial wormholes, is because that is the giving sort of wormholey reality to the sort of claim of quantum mechanics that
that ER, EPR things.
right. Can you interpret it specifically in terms of EPR?
Well, this is wormhole and it's entanglement. I think that's what it shows, right?
Well, this is an entanglement edge. Yes, this shows entanglement.
But it connects events in space-time. So it's actually, it's like a wormhole.
Yeah, that's pretty cool.
Okay, so your point is this is both a quantum correlation in the EPR sense and a space-time sort of connection in the ER sense.
Yep.
Well, that's interesting.
Nick, in your community post, did you mention ER equals EPR?
I don't think so.
You should write a bulletin on that. That would be really cool.
Yeah, and also the question would be, in the ER equals EPR kind of, so you're basically you're claiming this picture shows that ER equals EPR.
Well, at least it shares some intuition.
Yeah.
Right. I mean, you might be able to make a bigger version of this where you can actually see the development of a and I think Jonathan had some sprinkling way of getting, a space-time wormhole. And if you can do that, you might be able to see that, that there's a necessary connection between the multi-way part of this, the branchial part of this, and the space-time part of this. Yeah, this is a very nice thing. And even though the term branchial wormhole, which is a perfectly good term for this, takes a few steps to understand, I think. If I were explaining this, I would talk about there's a multi-way causal graph, and we're annotating the multi-way causal graph by adding, just like we can annotate a multi-way graph by adding causal edges, so we can annotate further by adding branchial edges. And in fact, is that something we've done? Given a graph, given a multi-way graph, we annotate it by adding causal edges. But we could also annotate it by adding branchial edges, could we not?
Yeah, we can. I think that was my first summer school project, when I tried to show it in 3D also.
Oh yeah, I vaguely remember this. Yes, I do remember this. So that's right, which is also somewhat related to things I was trying to do with multispace. But
Yep.
what you're saying is there is the multi-way causal graph is not the end of the road. The end of the road, the multi-way graph is, in a sense, what's really there. The multi-way causal graph is an annotation of the multi-way graph. And then the multi-way branchial causal graph is the full enchilada. Well, actually, it isn't even the full one, because there's even the real version of that. But that's at least a fair distance of the way there. And so then the claim would be that, the holographic principle and things, they have to do with projections in that graph. That's a cleaner way to think about it, actually, than to actually construct that fully annotated graph with both causal edges and branchial edges. And then to say, as you look at the ADS or CFT direction, you're basically filtering that graph to look at only one kind of edges. that seems like a reasonable way to think about it. And then the question is really, if for simple cases, what does that graph look like? For example, are there simple underlying evolution rules that lead to just some simple grid graph? Like I had some pictures of grid graphs where there's time-like directions, space-like direction, and branch-hill direction. But it would be really nice to actually explicitly construct such a combined time, space, well, essentially, multi-way evolution, causal and branch-hill graph. And then, see what we can get from simple underlying rules for that graph, because we may be able to see, for example, it may be obvious that CPT invariance, for example, follows that there's a invariance principle. I mean, we know that CPT invariance is related to rotations in that, branch hill, causal, etc. space. But it may be totally obvious from this graph that, in some limit of sort of computationally irreducible randomized limit of that graph, that it necessarily is the case that CPT invariance exists. That would be nice. At least approximate CPT invariance. And then, of course, oh boy, that would be interesting. I mean, we need a signature. Okay, we're off on a different topic here, but I mean, we need, in extreme gravitational situations, it's not obvious that CPT invariance is still valid. And this would show how that breakdown of CPT invariance might happen, which is relevant because it might lead to observable consequences, among other things. All right, this is really nice. Okay. For a different time. Let's try and schedule something soon. And we might want to break these, the physics discussion of that. And by the way, if you were able to make some samples of the combined graph, it'd be really nice. We need a sort of separate meeting about this pattern compilation stuff, I think. Because the pattern compilation stuff is working towards the multi function, is it not?
Maybe.
But the main point is this is all multi-way.
Yeah, it's like it's a replace list also multi-way, but this is just multi-way with additional information, with more details.
I mean,
Right, fully tagged so that it can have causal graphs and things like this, which replace list cannot. I mean, this presumably you could make a causal graph based on this, if I'm understanding correctly.
Yeah, you can deconstruct all this substitution object and extract all the things that it actually uses in theory. Yeah.
Right. Cool. All right. A lot of wonderful stuff here.
I think that, look, these developments on ER equals EPR, ADS, CFT, CPT invariance. I think the Institute, especially with the physics project, we should just start working on all this stuff. This is all super exciting. Yeah.
Yes, it is. It is. Very nice. Well done.
Well done, Nick. Wow, a Packlet and perhaps proving ER equals EPR.
Yeah, that's pretty good.
WPP is pretty good for one meeting, man.
Okay. All right, got to go to a different meeting, which actually is also being live streamed for those following that. All right, but if we can get something scheduled to continue with this sooner rather than later, that would be great. And for Ian, getting that recoloring stuff and some of those additional options would be wonderful.
Yep.
Okay,